Hello everyone, welcome to the pillars. So in the last class we have discussed about this Cauchy-Euler differential equation, and for general case I have told you how to find out the solutions, and by taking a second order which has the more probability to be asked in the exams. So I have done those things, and today we will do two more important concepts, because these are three sections from which they are asking frequently. They are asking questions right now, right? So let's start. First of all, we will see what is this Abel's theorem. Abel's theorem. So here we have to find out a quantity called Wronskian, that is written as W, capital W. Wronskian, capital W, and this is applied only we have a linear homogeneous second order differential equation. For example, let's say I have an equation y double dash plus p of x y dash plus q of x into y is equal to 0. In this kind of differential equations, they will ask Wronskian. And how this Wronskian is defined, let's do some mathematics and see how these things are formulated. Let's say for this equation we have two linear independent solutions. Let's say y1 and y2 are two linear independent solutions of this equation. Let's write down it as first equation. So y1 and y2 are two linear independent solutions of this differential equation. If y1 and y2 are two solutions, then we can write down, we can just put y1 here, then this will satisfy this equation, and y2 also satisfy this equation. Now we write down y1 double prime plus p of x y1 prime plus q of x y1 is equal to 0, and y2 also satisfy this equation. Then y2 double dash plus p of x y2 dash plus q of x y2 is equal to 0. Now why I am doing it? Because in a later case you have to know this y1 double dash and y2 double dash. So from this equation we will get these two values, and later we will use this. So y1 double dash can be written as minus p of x y1 dash minus q of x y1, and y2 double dash is equal to minus p of x y2 dash minus q of x y2. Right, now let's see what is this Wronskian. Wronskian, which is written as W, is the determinant of these two linear independent solutions and their first order derivatives. So we write it down as y1, y2, y1 prime and y2 prime. And this determinant is not equal to 0. If you see, this W is written as y1, y2 dash minus y2, y1 dash, isn't it? Okay, this is simple determinant value. Now we have to formulate a general formula for W, so that in exam you simply put that W and find out the solution, find out the answer. So what we can do here, let's take the first derivative of this W. So we can write down dW by dx is equal to, we have to use the product rule in both the cases. So you will get y1 y2 double dash plus y1 dash y2 dash minus y2 dash y1 dash minus y2 y1 double dash. If you see, these two quantities are equal, so you can just cancel this, and finally you will get dW by dx is equal to y1 y2 double dash minus y2 y1 double dash. Now I told you in later case you have to use these two. Now we put y1 double dash and y2 double dash here. By putting, we will get dw by dx is equal to y1 into minus px y2 dash minus q of x y2 minus y2 into minus px y1 dash minus qx y1. Right? Now px can be taken common here from these two terms and qx can be taken here from these two terms. So finally you will get dw by dx is equal to p of x taken common. If you take p of x common, then here you will get minus y1 into y2 dash, and here you will get plus y2 y1 dash. So we can write down y2 y1 dash minus y1 y2 dash, and by taking q of x common, we can write down here it will be y2 into y1, and here also y2 y1, but here you will get positive and here you will get negative. So y1 y2 minus y2 y1, and this gives to 0, and only one term is there, this one. Right? Let me remove this part. So here you can write down finally dw by dx is equal to minus p of x y1 y2 dash minus y2 y1 dash. If you see carefully, then this term right here in the bracket is Wronskian. W, you can see from here, this is equal to this one. So you can write down dw by dx is equal to minus p of x into w. Now we can separate the variables and find out the value of w. So dw by w is equal to minus px dx. Integrate both sides and take an arbitrary constant, that is log c, because here we will get log w. So by solving and rearranging, we will get w is equal to c e to the power minus integral of px dx. This is the general formula for w. Right? And now I will give you, remember one important thing. Here I have taken x as independent variable. That's why all the things are in x. But if you are asked to find out where there is t or some other variable are taken as independent, just be careful of that. And with respect to that, this will also change. Now I will give you two homeworks. You solve that and send me the solution, or you can watch the video on my channel. I will upload the solution video on my channel. The interested students can go and watch that, because the questions I am giving you to solve, I am getting very less response. So people are giving response, but very less. So I will upload in my channel. Whoever are interested, go and watch the solutions, or you can just send me the PDF of your solution. Now I will give you two homeworks. First homework, they are quite similar. For practice I am giving two problems. Now in first case, this is the differential equation plus 2 dx by dt plus f of t into x is equal to 0. And he has given that x1 and x2 are linear independent solutions. And a condition is given: if w at 0 is equal to 1, then find w at 1. Right? This is the first one, and the second one is quite similar. The equation is given 1 minus x square y double dash minus 2x y dash plus y is equal to 0. And it is given that y at 0 is equal to minus 1. So find W at E. So these are two problems, and here we have to take y1 and y2 as two linear independent solutions, right? So do this and send the solution. So without wasting any time, let me go to the next section, that is how to solve the coupled system where we have simultaneous differential equations. So basically we will have coupled differential equations. Now what is this coupled differential equation? So basically we will have two or more differential equations in which we will encounter two dependent variable but one independent variable. For example, let me take here, let me just write on coupled. Okay, so let's say we have dx by dt is equal to ax plus by plus f1 of t, and another one is dy by dt is equal to cx plus dy plus f2t. So if you see to these two equations here, what do we say this? The rate of change of x with respect to t depends on x and y as well, right? But previously, whatever we have done till now, we have not encountered this kind of situations. Whatever we have done, there is only one dependent variable and only one independent variable, right? But here we have two dependent variables x and y and one independent variable, that is t. So here rate of change of x is depending upon x and y, and here also the rate of change of y is depending on x and y. So what we have to do in this case? So how to do this, how to solve this the kind of differential equations? Let's do some mathematical formulation. After that I will give you some homework. So here what we have to do, we have to take d by dt as an operator, that is capital D. Now put this here and rearrange it. If you put here, this will be capital D into x and here ax. So let's take all the variable terms to one side and this function, let's keep this on right hand side. So what we will get, this will be dx and here it will be subtracted, then this will be capital D minus a into x minus by. So you can write down capital D minus a into x minus by is equal to f1 of t. And in the second equation, here only x term will be there, minus cx plus capital D minus small d. Capital D minus small d into y is equal to f of 2t. So these are two equations. Now what we have to do, you have done some basic things like to eliminate one of the variables here and find out one variable, and then apply this in one of the equations and find out the other variable. Same thing we will do here. Let's take this one as 2 and this one as 3. This one is 1. I am just neglecting it. So here what you can do, you can just multiply capital D minus small d in equation 2 and b in equation 3 and then add it. If you do that, then what you will get, equation 2 into capital D minus small d, and this will give you d minus small d into capital D minus small ax minus capital D minus small d into by is equal to capital D minus small d into f1 of t. Right? And if you multiply b in equation 3, this will give you minus bcx plus b into capital D minus small d into y is equal to bf2t. Now add both the equations. If we add, then this part will be cancelled and only this term will be there. Let me write it down. What we will get, capital D minus small d into capital D minus small a into x minus bcx is equal to, These two will be added. So after doing all the mathematics, you will get some function of t. So I am taking that function of t as r of t. Right. Now let's simplify this. What will you get? If you see here, this will be d square into x, then it will be minus a into d into x, then it will be minus d dx and plus a dx. So by doing all the simplification, we can write down capital D square into x and then minus a plus d into capital D into x, then plus AD minus BC into x is equal to R of t. And if you see this equation, this is a second order linear non-homogeneous differential equation, for which I have already told you how to find out the solutions. You have to first find out the complementary function, and then you have to find out the particular integral, and after that you have to find out the total solution by adding complementary function and a particular integral. So from this you can solve this one and you will get x of t, something you will get, right? And after that, take this equation 1. From this also you can find out dx by dt. You will get something. Now take these two values and put this equation. You will find out the y. So you can write down y h 1 by b into dx by dt minus ax minus f1 into t. This is the solution. How we get here? You can just simply see here. You will find out the value of x from this one, dx by dt from here, and put here. So keep this on this side and take these two terms to LHS. So it will be y, b will be divided here. That's why this one. So you got x, you got y. Now the coupled differential equation is solved, right? So this is the general formulation. I will give you two homeworks. This is the third homework. There are two homeworks in which two coupled equations are there. So the first one is dx by dt plus 5x minus 2y is equal to t, and another one is dy by dt plus 2x plus y is equal to 0. You have to find out x and y. And the second homework is very, very important because this was asked in just 2020, right? And I was very happy because I could solve that equation, and not by knowing its formula beforehand. I just sat in the exam and solved there only. I did it for the first time, and after that I came home and just took the book and saw how to solve that. If there is any hints, then I found in the book. So my answer was right. That's why I was very happy, right? So the second question is, this is the fourth homework in today's class. Two coupled equations are given as dx by dt is equal to x plus y, and the dy by dt is equal to x minus y. Yeah. So he has given x dot at t is equal to 0 is 0. Then you have to find out the value of x at infinite divided by y at infinite. And remember, what is this x dot is dx by dt. Then you have to put t is equal to 0. This is this condition. Okay. So solve these four homeworks and get back to me by Gmail or Instagram, or you can just match your solutions in my channel. I will upload those solution video also. And this is complete. From next class we will be entering into special functions, that is power series solution or Frobenius method. All the things we will be doing. And yeah, so that's it. See you in the next class. Till then, stay home, stay safe, and bye bye.